So good morning everyone. Today we learn polymorphism in Java. So what do you mean by polymorphism? Polymorphism means one object showing different behavior at different stages of its life cycle. So polymorphism, PHISM. So what do you mean by polymorphism? So let's take an human being. Okay. So if this human being is male, then at the early stage of his life he is a little boy or someone's son. Then at the middle stage of its life it is a someone's father. Then at the last stage of his life he is someone's what? Grandfather. Just like that way, as this human being is showing different stages, different behavior. When he is a little boy, he is showing his different behavior. When he is a father, he is showing different behavior. When he is a grandfather, he is showing different behavior of its life cycle. Just like that way, object in our Java is showing different behavior at different stages of its life. Okay, so what do you mean by polymorphism? So if we go for the definition, then we write here that definition, then we write here what? An object showing different behavior at the different stages of its life cycle is called polymorphism. Okay, so an object showing different behavior at different stages of its life cycle is called polymorphism. Now what do you mean by poly and what do you mean by morphism? So here poly means many. Okay, many. Poly means many and morphism means form. So one object contain many forms in his life cycle is called polymorphism. Okay, now we have two types of polymorphism in Java. We have two types of polymorphism in Java. So types is, one is runtime polymorphism and one is compile time polymorphism. Compile time and another one is runtime. Okay, so we have two types of polymorphism in Java. One is compile time polymorphism and another one is runtime polymorphism. Now we discuss one by one. So first we discuss compile time polymorphism. COMPILE, compile time polymorphism. So compile time polymorphism. So when we have a method declaration, okay, when a method declaration will get binded to its definition, so we have method and its declaration. So a method declaration, first we write the definition, then we understand what the definition tell. Okay, so compile time polymorphism definition is a method declaration will get bind it to its definition at the compile time by what? By the compiler based on the argument passed passed is called compile time polymorphism. So compile time polymorphism, a method declaration will get binded to its definition at compile time by the compiler based on argument pass is called compile time polymorphism. So what do you mean by compile time polymorphism? A method declaration will get binded to its definition. Okay, method declaration binded to its what? Definition at compile time, when the code is being compiled. Okay, compile time by the compiler based on the argument pass is called compile time polymorphism. So compile time polymorphism definition we write here. Now we understand the some key point. Okay, since method declaration will get binded to its definition at compile time, so it is called early binding. So why it is called early binding? Because you see here that in the definition we write that method declaration will get binded to its definition at compile time. That's why it is called early binding. So we write here what? We write here, since method declaration will get binded to its definition at the compile time. It is called as early binding. early binding. So as we see here that method declaration will get binded to its definition at the compile time, so we call it early binding. Very, very important. Okay, so now method declaration will get binded to its definition at the compile time. It is called early binding. Okay, now we give an example of method overloading. So method overloading, we give an example of compile time polymorphism. So example of compile time polymorphism is method overloading. So always remember, method overloading is an example of what? Method overloading is an example of compile time polymorphism. Is an example of compile time polymorphism. Is an example of compile time polymorphism. Okay, so method overloading is an example of compile time polymorphism. So what? Method overloading is an example of compile time polymorphism. Once method declaration will get binded to its definition, it cannot be rebinded. Hence it is called static binding. So method overloading or runtime polymorphism we learn here now compile time polymorphism. We learn here now compile time polymorphism. Compile. So compile time polymorphism is a static binding. It is also important. It is a static binding. Okay, it is a static binding. So if the question says why compile time polymorphism is called static binding, then you have to tell that once the method declaration will get binded to its definition. So you tell that method declaration will get binded to its definition. It cannot be rebinded. It cannot be rebinded, or we cannot rebind method declaration with method definition after the compilation. Okay, so after the compilation we cannot rebind again. Okay, we cannot rebind again. After compilation we cannot rebind again the method declaration with method definition. That's why it is called static binding, means we cannot change it. Okay, after compilation we cannot change it. So compile time polymorphism is an static binding. Why it is called static binding? Because you see here method declaration will get binded to what? Method declaration will get binded to method definition. Okay, one method declaration will get binded to method definition. Okay, so after compilation we cannot rebind it. That's why it is called what? That's why it is called static binding. That's why it is called static binding. As we cannot rebind it, it is called static binding. So we write here what? Once the method declaration will get bind it to its definition, it cannot rebind it. Hence it is called what? Static binding. So compile time polymorphism is once method declaration get binded to its definition. Method declaration here, it is binded to method definition. Okay, it is binded to method definition. Once it is binded, when compiled, then it cannot be rebind. Okay, that's why compile time polymorphism is static binding. Okay, that's why compile time polymorphism is static binding. Now we go for an example. Okay, so method compile time polymorphism example is what? Compile time polymorphism example is what? Compile time polymorphism example is method overloading. So we write here an example of method overloading. Okay, method overloading. So first we write what? First we create a class A. Okay, class A. Okay, so we create a class A. Under that class A we create a method void. Okay, add void add. Okay, in this method we simply System.out.println, in short form SOP, we print add 1. Okay, add 1. We just see the method overloading. Okay, here now semicolon, then we close this method. Now we create another method of same name, void add. Okay, void add. Now here the parameter is null. Okay, but here we pass one parameter which is integer type. Okay, int a. So now we System.out.println SOP. So System.out.println, here we write System.out.println is SOP. Okay, it is the short form of System.out.println. So SOP, here we write add 2. Okay, in add 2 we pass a parameter. Okay, now if we close the class, we don't close the class, we create a public static void main method. Public static void main. Public static void main method. String args. Okay, string args. Now we create an object of class A. So if we want to create an object of class A, we have to use the new operator here, new, and then constructor name. Okay, and we store it in a variable small a, and which is a class type. Okay, we store it. Now if we a dot add wait, if we a type. Okay, a type variable. Now if we a type, we store it a type variable. Okay, we store this object to a object location to a class a type variable. Okay, now we call this add method. If it is a non-static method, so we call it by an object. So a dot add method. Okay, a dot add method. Okay, and wait, we need some space, so we first delete this left one and we write here small form. Okay, so first we create an object with new and constructor name, and we store it to a variable a which is a class type. Okay, now we call a dot add method. Okay, add method we call here, and now we call a dot add method, and we pass a variable 5. Okay, we pass a variable what, 5, and now we close the main method and close the what, close the class. Now what will happen here, we understand. Okay, so what we done here, we create a class A, and under that class we create a method, add method, and under this add method we simply print add 1, and under this another add method, but here a parameter is passed. Okay, int a, and under this add method we simply print add 2. Okay, and now we here create our main method, and under this main method we create an object. Why we create an object? Because this to add method is non-static. When we call a non-static member from a static member, it is static, main is static. So when we call a non-static member from what, from a static member, we have to create what, an object. Okay, we have to create an object. So now what will happen here we understand. Okay, what will happen here we understand. So method overloading. So when we this function is a object name dot add, okay, this will work, this will go for what, this will go for this method, because here no parameter is passed, and this will go for what, this will go for this add method. That's why it is called method overloading. Method overloading. Here what is called in method runtime, an object showing different behavior at different stages of its life cycle is called polymorphism. And compile time polymorphism, a method declaration will get binded to its method definition at the compile time by the compiler based on argument passed. Okay, so here you see that based on argument passed, here no argument is passed, here no argument is passed, so null argument passed. That's why it is get binded to this definition, and here 5 is passed, that's why it is get binded to that definition. That's why it is called compile time polymorphism. So method overloading is an example of compile time polymorphism. Now we go for runtime polymorphism. What is runtime polymorphism? Okay, so here we go for what, runtime polymorphism. Runtime polymorphism. So what do you mean by runtime polymorphism? So polymorphism is two types. One is compile time polymorphism, another one is runtime polymorphism. What do you mean by polymorphism? One object showing different behavior at different stages of its life cycle is called polymorphism. Okay, so we know the compile time polymorphism. Now we go for the runtime polymorphism. So what is called runtime polymorphism? So first we note the definition, then we understand what the definition say. Okay, so runtime polymorphism, a method declaration will get binded to its definition at the runtime by the JVM. Okay, a method declaration a method declaration will get binded to its definition at the runtime by the JVM, at the runtime by the JVM, based on object created, based on object created, CREATED, object created. It is called runtime polymorphism. It is called runtime polymorphism. Runtime polymorphism, POLY morphism. So a method declaration will get binded to its definition at runtime by the what, JVM. So here the definition say that method declaration will get binded to it definition, method definition at what time, at runtime. Okay, at runtime, not compile time. Okay, at runtime. But here what the runtime by what, by JVM, based on object created, JVM based on object created. So method declaration will get binded to its definition by when, runtime by what, by JVM. When object is created is called what, is called runtime polymorphism. Okay, is called runtime polymorphism. Now since method declaration will get binded to its definition at runtime it is called late binding. So our compile time polymorphism is called early binding, but runtime polymorphism it's called late binding. Late binding. So why it is called late binding? Because first a code is compiled, then it is binded to run. Okay, so first a code is compiled, then it is run. Okay, so runtime polymorphism is late binding because method declaration, since method declarations will get bind it to its definition at the runtime. It is called late binding. It is called late binding. So since method declaration will get binded to its definition at runtime, so it is called what? Late binding. So why it is called late binding? So since method declaration will get binded to its definition at what time? At runtime. First compile time, then runtime. So that's why it is called late binding. Okay. Now method overriding is an example of runtime polymorphism. So example of runtime polymorphism. So example of runtime polymorphism is what? Runtime polymorphism, method overriding. So method overriding is an example of what? Method overriding is an example of runtime polymorphism. Method overriding is an example of runtime polymorphism. And compile time polymorphism, example of compile time polymorphism is what? Method overloading. So method overloading is an example of what? Compile time polymorphism. Method overriding is an example of what? Runtime polymorphism. Very, very important. It is very, very important. So method overriding is an example of runtime polymorphism. Method overloading is an example of compile time polymorphism. Method overriding is an example of runtime polymorphism. Okay. So now once method declaration is binded to its definition, we can rebind, hence it is called dynamic binding. Okay, so since once, so method overriding, okay, method overriding or runtime polymorphism runtime polymorphism runtime polymorphism or method overriding is called dynamic binding. Why it is called dynamic binding? Because of what? Once method declaration is binded to its definition, when method declaration will get binded to its method definition, okay, will get binded to its method definition, we can rebind it. Because we cannot run here. First, when compile, after compile we can rebind it. Okay, we can rebind it, then we again compile and run. Okay, that's why it is called, we can rebind it. That's why it is called what? It is dynamic binding. One more time. Suppose here is method declaration and here is method definition. Okay, so when it is compile, it is rebind. Okay, suppose we don't want to rebind this definition, we want to rebind another one definition. Okay, another one definition, then we create another one and then we again compile. Okay, so as runtime polymorphism, method overriding is an example of runtime polymorphism, so we can rebind again and again. Okay, that's why it is called dynamic binding. Okay, now we go for an example and we see here what is called dynamic binding. Okay, now we go for an example. So method overriding example. So suppose we have what? We have a class CLASS, class animal. Okay, class animal. This example is very important, method overriding example. Okay, this example is very important, class animal. Then void noise, noice. Okay, it is a method. Okay, and under that method we write System.out.println and same voice noise, okay, and then we create a class hyena. We create hyena, extend animal, which is extend animal. Okay, now we go for a method overriding example. Okay, so it is not a method overriding example. We go for a method overriding example here. So we go for a method overriding example in Java. Okay, so it is an example of this example we understand later because it is an heavy example. Okay, so we go for a simple example of method overriding. Okay, we go for a simple example of method overriding. So we create a class method overriding example. Okay, so we create a class vehicle. We create a class what? Vehicle, VECHICLE. We create a class vehicle. Okay, and under that vehicle class we create a void run method. Okay, void run method, and under that void run method we simply System.out.println vehicle is running RUNNING. Okay, running. Simply we print and close the method. Now we create a child class. So class what? Class vehicle. We create a child class. Of vehicle. Okay, so we create a class create a bike to which extend vehicle class. Okay, and under that we create same method void run, and we create same method void run, and we use the System.out.println, and bike is running here, running, and here we write bike is running, bike is running. Okay, bike is running, and we close this method. Now we create the main method. Okay, we create the main method. So public static void main. So public static void main, void main, void main string args, method overriding. So it is very important example. Okay, so bike, we create a object of bike2 class. Okay, we create a object of bike2 class. Bike2 object is equal to new bike2. We create a object of bike2 class. Okay, bike2 constructor, use construct. Now we if we run object dot run method, run method, then what will happen? Is it run this run method or this run method? It is the method overriding example. Okay, it is method overriding example. So it is method overriding example. So if you go for the example, so what we done here, you see here that we simply create a class. Okay, we create a vehicle class, and under that vehicle class we simply create a run method, and under that run method we simply System.out.println running. Okay, and under that we create another child class bike2 of vehicle class. Okay, we create a child class of bike2 of vehicle class by use the keyword extend. Okay, and under that child class we create another run method which is same as this run of void type, but here we print bike is running it. Okay, bike is running. Now public static void main string args, here we create the main method. Okay, and we create a object of which class? Bike2 class. We create a object of child class. And then we store it in object variable of class type. Now we call the run method here. Okay, run method here. So what is the output? What is the output of that program? You have to tell in comment section. Okay, you have to tell in comment section what is the output of that program. So now in this season we learn what is polymorphism, what is type of polymorphism, what is static binding, what is dynamic binding, all we cover here. Okay, and we also cover the two types of polymorphism, compile time polymorphism and runtime polymorphism with proper example. Okay, proper example. So hope you understand all. If you not understand, comment below, and if you have any doubt you also comment below. So the task 6, what is the output of that program and why? And why? Okay, you have to tell in comment section. Thank you very much. Have a great day, have a nice day. Happy New Year 2025. Thank you.